we now discuss the solution of a problem from the section Statistics and Probability. The question is related to probability in the context of one-to-one functions given in the question. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The given question is the probability that a randomly chosen one-to-one function from the set consisting of A, B, C, D to the set consisting of 1, 2, 3, 4, 5 satisfies f of A plus 2 times f of B minus f of C is equal to f of D is. We are given 4 options. Option A 1 by 24, option B 1 by 40, option C 1 by 30, option D 1 by 20. Required to find the probability that a randomly chosen one-to-one function from the set consisting of A, B, C, D to the set consisting of 1, 2, 3, 4, 5 which satisfies the condition f of A plus 2 times f of B minus f of C is equal to f of D. We now discuss the solution of the problem in detail. Let A be the set consisting of the 4 letters A, B, C, D and B be the set consisting of the 5 digits 1, 2, 3, 4, 5. Let's now consider the sample space. What is our sample space? The set of all one-to-one functions from A to B. Let S be the set of all one-to-one functions from A to B, and this will be the sample space in our case in this context. Now, what is n of S? How many one-to-one functions are there from A to B? N of S we have to find. For that, we recall this result. If the set A has m elements and the set B has n elements, and a necessary condition for the existence of one-to-one functions is m less than or equal to n. That means the number of elements in A less than or equal to the number of elements in B. Then the number of one-to-one functions from A to B is given by npm, number of permutations. npm, whose formula is n factorial by n minus m factorial. In our case, A has 4 elements, that is m is equal to 4. B has n elements, in our case n is equal to 5. So therefore the number of one-to-one functions is 5p4. n of S is equal to 5p4. Apply the formula 5 factorial by 5 minus 4 factorial, that is 5 factorial is equal to 1 into 3 into 4 into 5, which is equal to 120. And what is our event? The event is randomly choosing a one-to-one function satisfying a given condition. So let E be the event of choosing a one-to-one function f satisfying f of A plus 2 times f of B minus f of C is equal to f of D, which is same as f of A plus 2 times f of B is equal to f of C plus f of D. That means E is the set of all those f belongs to S. That means all those one-to-one functions satisfying this condition. And once you find this set, find out the order of that, that is n of E, and the required probability will be n of E by n of S. So now we will familiarize how to obtain the functions that satisfy the condition, this condition. So for example, you take a function f belongs to S, f is a one-to-one function which maps A, B, C, D onto 1, 2, 3, 4 respectively. That means f of A is 1, f of B is 2, f of C is 3, f of D is 4. Then in that case, f of A plus 2 times f of B will be, f of A is 1, 1 plus 2 times 2, that is 5. Can this 5 be written as a sum of these 3 and 4? No, it cannot be. F of C cannot be, f of C cannot be 3, f of D cannot be 4, and the sum is obviously 7. In any manner, So this shows that F doesn't belong to E. Further, if you know this, if G belongs to S, G maps A, B, C, D onto 1, 2, same as above. Instead of 3, 4, it is 4, 3. That means G of C is 4, G of D is 3. Even then, G does not belong to E. Take another example. If F belongs to S, F maps A, B, C, D onto 1, 3, 2, 5. Then F of A plus 2 times F of B, that is the F of A is 1 plus 2 times 3, 7. Yes, 7 can be written as 2 plus 5 or 5 plus 2. And that means you will get 2 functions which will qualify the condition. So this shows F belongs to A. This is one. The other is, if G belongs to S, G maps A, B, C, D onto 1, 3 as above. Instead of 2 pi, 5, 2. That means F of C is 5, F of D is 2 now. So even in this case, G belongs to A. So if one function satisfies, then automatically the next one will also be satisfied. So that means if one function you will get, then it will give rise to it. You can write the other function also, which is qualifying the condition. Agreed. Now with these few remarks, let's get into the enumeration, that is counting. So here is the tabular form. Now F of A is 1, F of B 2, F of A plus 2 times F of B is 5. Then what will be F of C and F of D? F of C and F of D can be 3, 4, 5. Other than this 1, 2. Other than this 1, 2. Can I write F5 as the sum of any two numbers of this set 3, 4, 5? No functions. So now let us say F of A is equal to 1, F of B is 3, then F of A plus 2 times F of B is 7, then F of A is 1, F of B is 3, F of C and F of D can come from 2, 4, 5, but 7 can be written as 2 plus 5, one function, 5 plus 2, the other function. So then you will get two functions. Then you will get two functions which will qualify this condition. Agreed. Next, 1, 4, no. 1, 5, no. So in this case, F of A is equal to 1, only one function will qualify. Next, F of A is 2. So you take F of A is 2, F of B is 1, F of A plus 2 times F of B is 4, F of C, F of D can be other than 1, 2, it will be 3, 4, 5. We cannot write 4 as the sum of any two numbers from the 3, 4, 5. Therefore, no functions. Next, no functions. No functions. Similarly, no functions. So, if with F of A is equal to 2, no function qualifies. Now, let us check. F of A is 3, F of B is 1. So, F of A plus 2 times F of B is 5. So, can this 5 be, and other than this 1, 3, F of C, F of D can be 2, 4, 5. We cannot write 5 as sum of two numbers here. So, no functions. Similarly, in this case, similarly in this case, similarly in this case. With F of A is equal to 3, no function qualifies. So far we have got only two functions. So let's get into the next one. The next one is F of A is 4, F of B is 1. Then F of A plus 2 times F of B is 6. And F of A is 4, F of B is 1. Then F of C, F of D can be 2, 3, 5. And can 6 be written as sum of any two numbers from 2, 3, 5? No. But now take F of A is equal to 4, F of B is 2, F of A plus 2 times F of B is 8, F of C, F of D is 1, 3, 5. So we can write 8 as 3 plus 5 or 5 plus 3. 3 plus 5 or 5 plus 3. So two functions will qualify. So no. So in this case, with F of A is equal to 4, two functions will qualify. F of A is equal to 5, F of B is 1, then F of A plus 2 times F of B is 7, then F of C, F of D belongs to 2, 3, 4, and 7 can be written as 3 plus 4 or 4 plus 3. So you will get two functions that qualify. And no. So thus we get how many functions are qualified? 2 functions in the last slide, 2 functions here, 2 functions here. The total is 2 plus 2 plus 2, that is 3 2s are 6. So n of E is equal to 2 plus 2 plus 2, that is equal to 6. Then the required probability is n of E by n of S, that is n of E is 6 by 120, that is 1 by 20. Let's look at our options. Our option 1 by 20 appears against option D. Therefore, the answer to this question is option D. And that is the detailed discussion of the solution of the problem, which is on the concept of probability in the context of one-to-one functions. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.